Hi, everyone. Who in here is not from Austria? Oh, that's a lot. If you want to say hi to anybody here, just say Servus. It's I'm super curious on how you're going to pronounce that, but mark those words. I feel incredibly privileged to be here with you and to be invited by this wonderful community, especially a community where I don't actively participate. So thank you for the invitation. Thank you, Julian. Thank you, Andreas, for having me here. I do have some connection to this event. Who here was at the very first StripeCon in Linz? Oh, quite a few. Do you remember this room? Yeah? Do you remember the wonderful view that you had across Linz? So this is Sam, and you can see the wonderful view across Linz. There's the dome in the back, and if you watch Sam's left shoulder closely, you can see my bam. You can see my. No, you can't see. Yeah, there should be an error. I'm super sorry. You can see my balcony over here. So you were watching my balcony. Come on. Okay. So, but I'm not here with you to talk about my balcony. I'm here to talk with you about JAMStacks, and I want to play a game with you. I want to play the game Guess the Technology Stack. A couple of web projects that are based on reality. I tried to anonymize them, make them a little different so nobody feels offended. But they're all rooted in reality. And I gave this talk 2 weeks ago at a different conference where one of the developers was in the audience and he started crying when I told those stories because he remembered what happened there. So first project, think of a web project about 10 pages of some intranet information. You know, a big company, they have an intranet, they have some telephone numbers, a campus plan, so you find your way around the campus. And the most important part is a menu plan for the cantina, for the cafeteria. This is the one thing that gets updated daily. The other things is getting updated 2 or 3 times per year, every time the summer intern joins the company and has time to do updates on the intranet. So what would you guess would be an appropriate tech stack for that? Any guesses? Like of course, Silverstripe. But it might be a couple of HTML pages that you publish. The company used a library portal based on JBoss, of course. It's like shooting with big guns on very small things. Why did you choose library to work with that? Because of the menu plan of the cantina. Because this was a portlet, you call it a Java portlet, that was easily integratable into library. But it took about, 5 developers for 6 months to create this intranet solution with library in the first place, just because of that little menu plan. Different project. Foodie Facebook. Think of 1,000 members having their own social network for food, for creating dietary plans, for having coaches that work with them on the diets. They can share recipes, they can like each other's recipe, they can connect them to a virtual fridge, where I know if you have all the ingredients that it takes for this particular recipe. And of course, there's interaction. You can comment, you can help each other. A wonderful social network with, about 1,500 users. What technology would you use for that, except Silverstripe? Or WordPress. Yeah, this was the reaction I was hoping for. It was WordPress because of a little plugin called BuddyPress, which provides social network functionality for WordPress. So they already went the first half of that marathon with BuddyPress, and the other half was 1.5 years of desperation. I have to give kudos to the developers because they know every line of the WordPress core in and out to make this happen. They had to make this happen. The thing is also they changed every line of the WordPress core to make that happen, which makes that projects still run on WordPress 2.7 to this very day. Ask your security folks if this is a good idea. The last project, an event page. Like here, like in the cinema. People can select an event, can select seats, can reserve seats for their friends so they can sit next to each other. There's an online payment system for that. Social sharing, of course, stuff like that. And this was done with the Java Enterprise application. A Java Enterprise application that published 20 JSON files and 7 PHP scripts every other hour to be up to date. And one of those PHP scripts handled the payment transactions on an unsecure connection synchronously with some payment provider. Yeah, so why did they choose this particular system? The Java Enterprise application was selected by the company, and the one developer was only able to code PHP. So this was their setup. And I don't want to blame anybody with the choices for this technology stack, because this is something every one of us has done to choose one technology for maybe a project where it's not the most suitable one, because those are the tools of our trade. So if you give a web project to a WordPress developer, they will do it in WordPress, no matter what. If you give a web project to a Drupal developer, they will most likely do it with Drupal or Type of Free or what else. If you give it to a Silverstripe developer, I heard great things about Silverstripe in today's keynote by Sam. I guess you will choose the right spot for Silverstripe in your web project. And I come to that later, actually. So, and the thing is, you know the saying that if you have a nail, if you have a hammer, everything looks like a nail. But a web project is much, much more than just nails. There's a couple of layers. Like the front-end layer. This is the layer where I come from. I considered myself to be a front-end developer for a long, long time. And all I care about is having great accessible and semantic markup, having CSS and JavaScript deployed. I don't care a lot about the rest. Then there's the CMS layer. CMS people care a lot about data, structures, and of course editors. So Sam mentioned that the Silverstripe CMS is loved for its great UI and intuitive UI to edit those data into structures, to have those models editable. There's this application layer. This is all about process and state and transforming stuff to be suitable for what you have on the client side, or storing stuff in the right way, or just connecting some APIs together and producing some results. And the last layer is the hosting layer. People from hosting care about availability, stability, scalability, and security. And those are not only layers in a web project, those are actual teams in some agencies. So an agency I worked for, we had 4 teams for web projects, one front-end team, a CMS team, an application team, and a hosting team. You could argue if this is the right way to structure a company, but this is not part of the talk. It can be a person, not a team. And for lots of web projects that I worked with, everything revolved around the CMS layer. And for good reason. As said, this is the one thing with the editors, where you edit data, where you give your users, your clients, the ability to produce their own content for the web. And this is why the CMS layer is so important. Nobody cares if you use PHP, Java, or any other technology, as long as this data is wonderfully editable and people can see results. But there's one thing more. There's not only your clients, there's also all the users out there. Come to that in a second. If we choose one particular technology, which we try to create everything with, like WordPress or something else, this can lead very fast to technology login. The way you produce your frontend has to work with the way WordPress thinks to deliver frontends. I remember every frontend, every WordPress site that I set up had about 10 versions of jQuery at some point because of all the plugins. And I was wondering, what if we don't focus on the CMS layer, but focus on one layer where all your users care about, like not the clients, but the users of that web page, which is the front-end layer. Nobody accessing your website cares about having Silverstripe in the backend, having WordPress in the backend, having Drupal in the backend, or whatnot. They care about the markup that's delivered. And how do they care about? Well, does it show content or doesn't it? Or is it accessible? So let's try to put the front end in focus and see how all those layers revolve around the front end. So when I was doing front-end projects back then at the agency, we helped ourselves by using template languages like Liquid, Twig, Handlebars, always one of my favorite template languages, to create modules for the front end that we are doing, which we can fill with pseudo-data or maybe even with real data, and where we were able to track the progress of the front end we were developing. And it's just a little step from a templating language to a static site generator, which is a templating language which produces actual HTML with real content that can be accessed. We heard Gatsby today in the keynote. Gatsby is at the moment one of the most popular static site generators based on React, but there are tons out there. So if React and Node is not your thing, which I can understand. I use it a lot and I love it, but I can understand that some people don't like it. There's static site generators written in PHP, in Ruby, with entirely different languages, or even with systems where I don't know which language they're using. And there are tons out there. And the idea of a static site generator is to have templates on one side, content on the other side, and combining both of that through a wonderful animation to actual HTML pages. Actual HTML pages that you can deploy anywhere. This is an example of some Liquid code for my blog. This is some Markdown that I've written about JAMStacks. This stuff gets put into here, done, we are ready with our website. And this sounds very simple, but this is actually a major architectural shift. So usually when you had traditional projects, everything was kind of a pull architecture. So you had the request on one side, going for routing. Routing says, okay, this is my nice blog article.php or whatever. Calling the renderer. The renderer says, please give me the HTML based on that route. Renderer goes to the database, fetches, or the data storage, fetches all the content, renders it into HTML, puts it out to routing, puts it out to the client. And with static site generators, everything is push. So you have all your data at once, pushing it through a rendering engine, creating all the pages up front, and pushing it out to the web. So the client just calls some storage if the HTML page is available, and the server or the storage delivers this HTML page. That's all there is to it. So let's think about what an effect something like a static site generator has on hosting. You remember this wonderful architecture diagram? This is now some random server on the internet, but it can also be every content delivery network in the world, like AWS S3 and the CDN, it's CloudFront. I need Merriam-Webster's dictionary for AWS abbreviations in English because I hardly can remember all those abbreviations. This can be really everything. So some people use the Dropbox folder to store static HTML, or S3, or Azure Storage, or any place, actually, which has some great effects on availability, for example. Suddenly, you're not only hosting them on one spot, like some EC2 instance or some server at Hetzner or wherever, but you can host them everywhere through CDNs and through static storage, which is cheap. And it has some great effect on availability and resilience. So this is one documentation page that we did, running on slow 3G, and it feels almost instantaneous when you click through it. And there's no magic behind it. It's just cache all static assets as good as you can and deliver just the HTML page to the client. It's just one HTML page. There's no server-side calculation. It's just fetching the page, delivering it. So on the plus side, we can connect Markdown, JSON, any API for data to create static HTML pages. And those static HTML pages, well, it's just HTML. you can host it everywhere. With that, it becomes really scalable. So you don't have to spin up another EC2 instance just to make the load work that your website gets. You can just deploy it on some other static storage. It doesn't even have to be in the same system. It can be Azure on one side, AWS on the other side, or something in between, or just having a Cloudflare layer around it that deploys it or that makes it available across the globe. The thing is super secure. So when we started with that, with just an EC2 instance, before we did some fancy storage and CDN stuff, we were deploying just read-only disks. There was no way to have write access on the disk. So the thing is as secure as your client-side code is secure. Nothing to care about what's going on in the backend or going on in your data storage. On the downside, it needs a build process. The build process can get really, really long when your site grows bigger. So get speed takes about 2 minutes just for a simple hello world. We had a project running on Jekyll, which is a Ruby-based static site generator, which took about 2 hours for 20,500 pages, which is a lot. And we were able to break that down through incremental updates and big technology change from something Ruby-based to something Node.js-based to about 2 minutes. So you really have to know your build system and your static site generator if you want to go that route. Static site generators are really not good with binary data, so there are some static site generators out there that touch every file and look if there's some template code to replace in there, which is good for every file like CSS or JavaScript or HTML that you want to deploy, which sucks a lot if you want to go to 1,000 images. And some static site generators are more flexible than others. So some static site generators allow you to select the types of files you want to go through and replace content with. Hugo, for example, is a static site generator based on Hugo, which is super fast, super reliable, but not as flexible. So you can't extend it with plugins or something else. But hey, we switched to static site generators. We focused on the front end. We took care about delivering great markup, HTML, CSS, and JavaScript. And it has some great effect on hosting because suddenly we just can deploy HTML across the globe. And let's think about the other layers. Let's think about content. There's one project out there. This is the Azure documentation, which I like a lot because there's this one little edit button on the top right corner. And if you press it, you get to GitHub, and you can edit the very source of this page, do a pull request, and update the documentation. There was one documentation out there, I forgot which one, which even had code snippets unit tested during build time, which was a really nice touch to it. So they were not only deploying fast websites, but also making sure that the content really, really works. The cool thing is, once you do a pull request, this is something that we did, we can do a preview build. Like we can take this one branch from GitHub, render all the new content, deploy it on some internal server, and make it available for our content editors. This is our Bitbucket system, where we get from the build master preview links to all the changed content, which is really great if you do content staging. Think about having version product releases and having a version documentation right next to it, and you deploy them both at the same time. And suddenly your content becomes code. So all the code workflows apply for your content as well, which is great if you're a tech-savvy user, like I assume everybody here in the audience is, which is not so good if you have real users out there, real content editors who want to change stuff and have to learn Git first. So I know a lot of developers who struggle with Git. Think about people who never did any versioning or any software development in their entire life, and they should work with Git as a content management system. And this is where we should go headless. And this is also there's also a lot of things in Sam's keynote today that really made me happy because there's a strong focus on providing a good editing experience and making all the things around it very, very flexible. So this is a very good route. I'm really happy to see that for Silverstripe CMS. One CMS that I'm using a lot is Storyblock, which is a commercial headless content management system. But it's one that not only has a great editor, but it's a vendor that doesn't fuck with you, if we have to put it in a very, very harsh context. They are made for developers, so you get things like S3 backups with every deployment for free. You have good plans if you're a small agency or just a freelancer to work with that without needing to pay anything. So good free plans, and one content management system that I can recommend if you want to try out going fully headless. And the cool thing is, if we focus on our content and not just on the front-end layer, we again get a content management system, not a content design system. I still get nightmares from all the colors our editors put into WordPress to make something underlined and red where it shouldn't be. Also, we're 100% output independent. We're not only publishing static HTML, but you can connect it to some iOS app or wherever, or just consume it at other different places. Commercial headless CMS have good, free, and cheap plans. And one of the most important benefits is that the CMS status is totally independent from the site status. So if your CMS burns down in flames, the site still works because it's hosted somewhere entirely different. On the other side, Git as a content management system doesn't work, so you have to go headless if you want to make that really happen. To this day, I don't know of any good open source alternative, but as said, what I've seen of Silverstripe CMS today really, really makes me happy and makes me want to try it out. This is also something where I think the open source community has some potential, or has some let's don't call it niche, a place to evolve. I know some content management system that I worked with, like type of free or Drupal, where they have some sort of headless route, but are still not sure how to handle that. I have the feeling that WordPress is going to be fully headless in a couple of years, but I still haven't seen this one content management system that embraces headless for what it is and works well with all the ecosystems around it. And I think betting on GraphQL was really, really a good choice, especially for if you consider JAMStacks and static sites. Also, if you go for commercial headless content management system, if you are a big user, you pay big money. So prices try to really have a hockey stick once you have a certain amount of users. And you always have to think about your content exit strategy. Relying on some vendor and some company to store your content in your data can be really tricky if you want to move away from them. So instead of a technology lock-in, you get a vendor lock-in for a content management system. So always think about how easy it is to remove your content from that platform again. But hey, we were focusing on the front end, and it actually has some good effect on the content management layer. We can focus on editing again. We can focus on providing editors for data infrastructures and making them available for everything else. Now let's see how the last layer works, the application layer. And when talking about the application layer, I want to talk about serverless. Who in here knows about serverless? There's a talk tomorrow about serverless, I guess. If you haven't heard about serverless, it's always advertised as it's not about having no servers, but it's about not caring about servers, which is a phrase that has been used a lot. I like to think about them as functions as a service, which is you have an endpoint somewhere that you can call, and serverless platforms just execute the code that you are running there. I like to compare it like developing for a browser. Every time I create a web application for the browser with JavaScript, I just deploy my JavaScript. I don't deploy the browser with it, unless you use Electron or something like that. And with serverless, it's somehow the same, but for servers. You just deploy your code. You don't care about, is the right version of Node.js on there? On which server runs Node.js? Is there a recovery strategy? Is there some error strategy? This is all taken care of you. You just deploy a code, and the platform runs the code for you. So like you develop JavaScript for the browser, it's developing for the server. Except that there are many more languages available. So most languages I've worked with on serverless platforms is, of course, JavaScript, but also C# and Go, funnily enough. I think one of the most interesting languages for serverless is PHP, because PHP was built for serverless even before serverless existed, because you just call an endpoint, and just the code that you have is getting executed and produces a result. And this is all about serverless. So everything that PHP was mocked for a couple of times in the past is actually becoming on vogue again, because people really see value now, not that they had to work with Node.js. One thing that we did, for example, with serverless is the search over here. This is just an input field that calls an endpoint, and we get the results, the search results back based on a query string. We even deployed the serverless app with every deployment of the website. So it's a read-only serverless app that has a complete search index deployed with it. And it has it's called Luna.js, which is a client-side JavaScript-based search engine. But hey, it's JavaScript, so you can also run it on the server side with Node.js. Just as a function, I don't know, about 100 lines of code. And we had a fully available search that was also very fast. So we later exchanged it for a commercial search solution, which never got the right results, nor was it fast enough. But hey, technology. One project that I really, really like, which is also going the serverless route, is Smashing Magazine. Who knows Smashing Magazine? Yeah, quite a few. Which is my most favorite resource for web development. This is the membership area. So if I click on membership, I can, buy a membership. But if I already have a membership and I log in, the whole page gets swapped on the client to my membership area, where I see, all the contents that I've purchased, like my free webinars or ebooks or whatever. And this is done on the client side. So it's just one ping to the server. Is this user logged in? Is it a valid membership? Please send me back all my membership content. And when you are a lot on Smashing Magazine, this switch of contents is almost instantaneous. You don't see the other page. I had to fake that for you. One thing that always bugged me was sending emails with a web project, always configuring send mail and having the right PHP APIs or having some WordPress calls that didn't work. I'm bitching a lot about WordPress. I'm very sorry about that. Good to know. With serverless, especially on Azure, with Azure Functions, this is all I needed to write some SendMail or email program. I use a service called SendGrid over here that delivers the message that I built above. Just a couple of lines of code. It used me about 30 minutes to read through the documentation, connect all those parts together, write that code, test it, deploy it, execute it. And maybe I should spend some time into security here as well. But it's just, just that you get some idea on what it takes to create a full email service for your website if you use serverless. There's also one technology called HTTP headers that can be really, really useful if you do serverless. For example, the accept header. Every time I'm on the client side and I want to retrieve search results through Ajax, through a fetch API, the browser sends this application header accept application JSON with it, which allows the serverless app to deliver JSON back. Cool, I get JSON back, I show the results on the client, I have an interactive web page. If I press enter and I go to the same URL through a form element, the browser sends the accept text HTML header with it. And with that, I can tell my function, please deliver HTML. So you have both cases done with just one endpoint in a serverless context, and it works just as well. If you're working with React, you might have heard of Next.js. And Next.js is also one of those frameworks around React that go full serverless. So it's static or server-side rendered first, but running server-side through serverless, through a function, and it also works with accept headers. If you get accept text HTML, one URL gives you just HTML output. If you call it with the wildcard accept header, which you get if you do, I don't know, inserting a JavaScript file into your markup, you get just the JavaScript content that can be swapped on the client side. So you get also this nice dynamic feel of clicking on a page and having the results instantaneously back without having this blank page when you do go from one request to the other. All done through serverless and through accept headers. One cool thing about serverless is that you just pay what you need. So you deploy your code somewhere and you just pay for the execution time of it. It's not even a cent. I guess one execution is 0.002 cents or something like that. So before you pay 1 cent, you can have about 500 executions of that functions, which is good for small scale websites, and also scaled really, really good if you have big scale websites. You also have a manageable attack surface. So this is, again, the whole talk about security. If I know that one of my functions might cause a security problem, then I just switch off this one function, and all my other functions can still run and still can produce content. I have defined input and output. This is also, just like a function, just like in the programmatic sense, a function. And since everything runs with APIs, integration with third-party services is really, really easy. So lots of third-party software as a service solutions have really good APIs and connections to serverless platforms. On the other hand, serverless architectures are hard. You just have to think about not only microservices, but nanoservices, like this particular small function. How does it integrate with all the others? If you have complex tasks and lots of asynchronous tasks, this can get really, really hard. And also, I made this analogy with browsers. Everyone who worked for browsers in the early 90s or late 90s, who had to deliver content to Netscape and to Internet Explorer back then, knows how different those platforms were. And we are at the same spot now with serverless platforms. So if you want to write one function for Azure, it's entirely different than writing it for AWS Lambda, or for one of those solutions like Netlify or Site, where they have a wrapper on top of that. Or if you write it for the serverless framework, which is a framework for serverless on different platforms. So it's like the jQuery of serverless right now. And we are still at this very early stage where we haven't found this common ground of writing functions for all the platforms in the same manner. Also, functions are stateless. It's just a function. It's like in functional programming. If you want to have state, you need to have some sort of memory, some sort of storage where you connect to. You have to think of it as this function that just spins up, executes a code, and is thrown away again, which makes already also very, very easily scalable. If you have lots of traffic, it just spins up, I don't know, about 1,000 times the same program again and again, and then throws it again away. And the more interfaces you have, the more contracts that you have, and contracts is, again, a security problem. But all in all, we focused on the front end, and suddenly it has some beneficial value on the application state. This is also one part that I want to stretch here, especially when you work in teams. Suddenly you don't have to have an application developer who is working mostly with PHP, have to work with a Java environment just because the content management editing interface dictates it to be, or because the front-end code, like this one menu plan, wants it to be Java. They can write the code in PHP, run it in a serverless environment, and just connect it to everything else that is put out there. Yeah, and this set of technologies, environments that we have, is collectively known as the JAMStack. I'm not particularly happy with the term, but it's a name for something that people did for a long, long time, so it's good. And JAMStack stands for JavaScript APIs and Markup. Markup, we've seen that's templated markup, pre-built at deploy time. And this is something that's super important. Even if you have lots of enhancement afterwards with functions or whatnot, everything that can break, everything that's dynamic and can burn down, this is still markup that runs, that exists, that is delivered, and that's content for your users that they can read. No matter the status of your serverless platform, no matter the status of your content management system, all you need is some stable hosting to deliver that markup. If everything other burns down, this still works. Then you have APIs. That's your serverless apps. That's some other apps running in the wild that you can connect on the client side through JavaScript, and where you can enhance your app pages with dynamic functionality, a search, a contact form, whatever. And then the last point is JavaScript. Everything that's done dynamically should be done on the client. I'm not particularly happy with that part because I like to do server-side serverless a lot, which kind of contradicts the statement. But without it would just be the M stack. So I think it's okay to have this J in there as well. And all you need to do to run JAMStacks sites is you have some place to build the whole thing, like some continuous integration environment, some place to deploy the thing, like Azure Storage, AWS, S3, whatnot, and some place to enhance everything through serverless functions. There are 3 vendors that I use regularly, which one is Netlify. You've heard Netlify today in this keynote, which focuses on builds and deployment. So there's immutable deployments for every version of your site that you do. It has some prepared functions for common use cases. You can write your own functions with an easy-to-use API as well. And you are cloud ready for most websites. One vendor that is kind of similar, but a little bit different in how things are executed is Site. Site's Now platform, which goes first and foremost into the serverless route. So everything they do is serverless. You deploy a JavaScript file, it's serverless. You deploy a PHP file, it's serverless. You deploy a Go file, it's serverless. They have builders for almost every technology. I was able to spin up a Rust app serverless within seconds, which has some great startup time. So Rust is very has high potential for being a great serverless technology if the environments get it right. So if you want to try out serverless and have a truly serverless platform, this is Site. But we are not only caring about serverless, we are also caring about static sites, of course. And static sites just go along with it. So the routing in Site works like that. Is it some programming language? Run it serverless. If it's just HTML and CSS, just serve it statically through the CDN. So it's infrastructure-wise, it's the same, but the approach is different. Where Netlify cares about static sites first and then enhancing it with serverless, Site cares about serverless first and says, okay, static just tags along. And if I want to go enterprise, I use Azure a lot because, as said, I don't want to use the Merriam-Webster dictionary of cloud abbreviations for it. And it has such great names, like the Azure DevOps is for DevOps things like CI/CD, build pipelines, etc. Azure Storage, it's a storage. Azure CDN, well, it's a CDN. And guess what? Azure Functions are serverless functions. And by choosing one of those platforms, or maybe all of them, you don't have a technology lag anymore, and you can go incremental with that. I guess this is one of the most important things that I want to stretch about the JAMStack, that you can start right away with a small piece of your current website, no matter the stack you use for your website, and use JAMStack and enhance on top of them and incrementally adopt it. So, for example, this is an old LampStack site with WordPress, and I want to have a JAMStack frontend at some point. Well, just use Gatsby and use the WordPress GraphQL layer to fetch data and to create those Gatsby pages. And you can store them right next to your WordPress page. You just have to configure your Apache to deliver those statically generated websites differently than your PHP websites. And as you continue and work over time, you can replace even more things, like maybe some application parts with functions, some content that's edited in Storyblock or Silverstripe CMS or wherever instead of WordPress, and still run your old LAMP application right next to it, and then over time silently remove everything that was of the old architecture. And if you have chosen one stack for your application, like in this case Jekyll, Storyblock, Azure Functions, and Netlify, it's super easy to add more technologies to it if they are more suitable for that. Like having Auth0 for an authentication layer, because you don't want to handle authentication on your own. You use a third-party provider with that. Or having some RSS feed from your, let's say, podcast provider connected to it and create a nice podcast overview page for your site. Just add another resource to it, just another API where you fetch your data from. And if you're not happy with Jekyll at some point, don't worry, you just can drop Jekyll, add Gatsby, drop Jekyll, add Gatsby, exactly, or any other technology. We did that in the past. So when we were working with Jekyll and our builds took about 2 hours, we spent, I would say, 4 weeks, it was a big page, to remove everything with Metalsmooth, which is like Jekyll for Node.js, which brought down our 2-hour build time to 2 minutes. So this is easy. And this is done by the people who know their stuff in that area. This is not done by the Java developer, this is done by your front-end developers. They know how to create markup, they know how to create CSS and JavaScript. To sum it up, some good things about the JAMStack. Every piece is independent. You have your application layer, and you can replace your application layer as you see fit. You can start with your Java backend or with your PHP backend, like you're used to, as long as the API stays the same, as long as the URL and the output stays the same, you can swap technologies there as you see it fit, or you can add other technologies that might be more suitable for that as you see fit. JAMStack sites are resilient. Everything burns down in the application, your static sites still exist and can still be viewed by your users. They are fail-safe and they're sustainable. You can incrementally adopt. You can start with a JAMStack site right away and replace all the old pieces bit by bit. And you get full control of every part in your app, which also means that people who work with their technologies are able to work in their field, and you don't have to adapt to some weird front-end language or some weird back-end language if you don't want to. I still have nightmares from this one typo-free website where we did the whole, except that it's typo-free, where we did some really advanced business logic through plugins and not putting out JSON APIs, but working with their fluid templating language to kind of make that work. And this was something that didn't scale, where we didn't have the knowledge for it, where we just had one person who was reading documentation on the weekend to be able to work on that for the next week, because we were selecting typo-free and we didn't think about having our own application layer next to it. On the downside, you don't have a technology lock-in, but we have lots of technologies, so this can lead to fragmentation, which is always something you have to keep in mind. So if you go for one particular route, and if it's an exotic route, make sure this knowledge for this technology stays within your company or within your project. We are still very platform specific, so Azure works entirely different than AWS does, or that Netlify does, or Site does. One problem that you might have is not having technology login, but vendor login. So always think about exit strategies, and also be aware that this is third-party land. So if you don't want to work with certain things, you always have to connect to third-party services like Cloudinary for images, Auth0 for authentication, and whatnot. Well, and with that, I want to close it down with some wise words of a hopefully wise person who said, every website and web app that can be done with JAMStack should be done with JAMStack. And to give it more emphasis, I think every website can be done with JAMStack. And with that, I want to say thank you very much. Thanks for having me, and thanks for this wonderful opportunity.
Thanks a lot, Stefan, for this wonderful talk about JAMStack. I think I learned a lot. Yes. And yes, so if anyone has questions about JAMStack, feel free to ask Stefan. He's around here. Yeah.
Thank you very much. You were mentioning that given this search function, you can return either JSON or a rendered HTML. How do you cope with it that for rendering the HTML you need the markup as well again? And how do you deal with that you don't have to manage it?
So one particular thing about that particular app was that our whole serverless app was deployed with every static site deployment that we did. So everything that we did was immutable. Every time we had a content change, we were exchanging our whole application, our whole static sites, as well as our Azure function. Was it Azure? No, it was AWS Lambda, as well as our Lambdas. And this one function was constructed in a very interesting way, that it had some HTML don't call it framework, some sort of boilerplate or template that we created on build time, which we required with every execution of that Lambda. So it was basically one big string with one placeholder for the content, and the Lambda did nothing else than running Luna to get some search results, creating some markup for that, putting the markup into this template, into this boilerplate, and delivering that HTML out there. On the pro side, this is up to date with every deployment of our site. Great. On the downside, this templating process takes some time. So if we just get JSON, we were talking about, 100 to 150 milliseconds of getting the data across the globe and showing results. The templating process added another 200 milliseconds on top of it, which is still less than 400 milliseconds. But we wanted to be the fastest website on the internet, so that was kind of a big deal for us. And you have to get creative, so you can't just store some pre-built markup or something like that, because there's no state. You execute the function, you throw away the results afterwards. And this can lead to some performance troubles in the long run. So you really have to optimize for these short-lived functions that you have. Yeah, I guess that's what it.
What was my question? So you need some solution to render the markup as well.
Yeah, absolutely. We integrated handlebars first, but then you have the whole weight of handlebars with your short-lived functions, and this doesn't work out. So if you go with Node.js, there's this one thing called NCC, the Node Compiler Collection, which basically creates one JavaScript file for your serverless app, even if you have it structured in many files, which is really important if you add Node packages and third-party libs to it, because the biggest performance problem in Node.js is file I/O, funnily enough. And if you have it just in one file, Node gets a lot faster with it. More questions?
Yes, okay.
In your stack, it was Netlify, Zeit, and Azure. I'm curious to know, are there particular reasons for Azure over AWS?
Yeah, so the reasons, give me a second, you mean this one?
No,
this one?
Why Azure, not AWS?
Why Azure and not AWS? Okay. AWS for me was always like very hard to get into. So the start for me was very, very tedious. I think if you master this one hurdle, that you can move around really, really good. With Azure, it was just easy for me to create something like that. So they had good documentation and good start. And I'm a front-end guy. I don't care about infrastructure a lot, or I don't work with infrastructure a lot. And Azure made it possible for me to feel like a cloud infrastructure guy in just a couple of hours. I think the project called AWS Amplify helps a lot to get people going with cloud infrastructure. So kudos for that. Other than that, everything that you've seen from the Dynatrace project runs on AWS, but it was done by the infrastructure team, not by me. That's why I can't tell stuff about it. And also, I hopefully get MVP credits at Microsoft if I put in the Azure logo and not an AWS logo. And if you wonder why I have Netlify as a hosting and Azure Functions for my application layer, this is just to show different logos on that slide. Nothing more.
Okay, I also have one question.
Yep.
When you have your CMS, maybe WordPress or Superstripe or whatever, and you want to rebuild the Gatsby site or the static site builder, do you have any automatic solution, or do you have to rebuild it manually? Do you press a knob somewhere?
This is the whole DevOps part of it. So this is also where are we? Netlify and Zeit try to be very so Netlify and Site both have build mechanisms, and this is a very important part of it. So we run Jenkins in our company to build those things. For my personal projects, I use Azure DevOps, which is also an online build system, which you need, and hopefully they are not only just triggered by you, but by some sort of hook. So it's harder with WordPress to have a hook where you press publish, then a hook calls some online service like Azure DevOps or whatnot, or Travis CI or Circle CI or whatnot. It's a lot easier with Storyblock, where they actively ask you for a publishing hook once you hit the publish button. So you as an administrator of Storyblock have to enter some sort of publishing hook if you want. And this hook gets called every time you publish something, then the build triggers. Most of them are optimized for Git as well. So if you always have a push in master, a build triggers. So yeah, this triggering the build is really, really important for the whole thing. You don't want to do that manually. You can if you want, but especially if you're paid by the hour. But I don't think this is something that's sustainable for the future.
Silverstripe has some ideas about static publishing since years in it. Like there's a static queue publisher and everything. You don't have it separated like this. The framework will do the publishing and it creates files. And we used to do that. We had our entire site static published, had an Nginx in front of it, and it was like really fast. It was the nicest thing ever. The problem we ran into is we had about 180,000 detail pages that were updated multiple times a day because of pricing data, availability information, and so on. And our build queue got so long that we couldn't keep up. And we noticed that we were building pages that no one was looking at. Mm-hmm. Like, so my question is, how would you like approach something like this? Mm-hmm. I mean, the nice thing was we had a constant load on the system. No matter if we had one user or 10,000 users, the system would scale perfectly, and we had a constant load, but we couldn't keep up.
This is the same problem that all those ridiculously overpriced enterprise content management systems had. They were like, no, static publishing is not the feature, it's our main way of doing something like that. And you had this huge monolith of Java application run on some editing server, and then you had a publishing server, and then you had a delivery server, and you were paying people for all the infrastructure and paying people for all this content management stuff here. So I know of a project which is about the same size, which ran for a day and a half. To publish all those sites, and this is just ridiculous. So I think if you have a project like that, where the build time takes a lot longer than you would anticipate, it's totally safe to have a very good caching layer on front of it, where you just fetch those HTML. So it doesn't mean that you have to build your static HTML with a static site generator or with a pre-built step. If you can ensure that everything you deliver is just static HTML. And there are some caching solutions out there which are so-called lazy. They always deliver a result directly from the cache and then ask in the back if there's some update and fetch the newest update. That works totally fine. You have some connection with the hosting layer and the CMS layer again. So if you want to split that up, it might not work that well. But it's a reasonable thing to do if your site demands it. As said, static site generation, the bigger your project gets, the bigger build times are. And this is a problem, so this is something that people are also actively working on. I think something like incremental updates, like knowing exactly which content has changed and just updating the content that has changed, is also something that's very, very interesting for content management vendors. Not just having a publish hook for, hey, we have an update, please fetch everything, but hey, we have an update and this has changed, and just produce the website, the pages for this. This might really something that needs to be considered. But that said, this tech is very new, and people are just actively adopting it. So I think that will be something in the future, hopefully. I know that Gatsby is working on that. Yeah.
And second question, if I may, how do you deal with user-generated content or input in a setup like this, where it might be relevant on different pages.
Let's think comments, for example. So comments for us is an application that runs entirely on its own. It's a serverless function that accepts the comment, checks it if it's, not some spam or something like that, stores it in a database, and you have also a hook where you get all this data, and it's just injected on load asynchronously. The service Discuss works like that, but sites like Smashing Magazine did their own way of that with Netlify, so Netlify has now a service for that as well, which is the reasonable thing to do. User-generated content is always this enhancement step. And this is also the step where your where the lines between a traditional website and a dynamic web page kind of blurs, which is good because it should be. I think they're the same thing. It's just different approaches on how we tackle a thing. And with JAMStack, you have some sort of common line. The static site can be just enough to have the minimum needed amount of content for your users, so they don't ask themselves what's going on there, and then enhance everything as you see fit. So this is a totally reasonable thing to do.
Thank you.
Righty.
Do you see any increase or decrease in your Google search rankings for your websites that you replaced by JAMStacks?
I can't tell you for sure because I just did very little with Google with the Google search results. But what I know is that what worked really, really well is having super fast websites. So we spent a lot on the page speed score, that we have a speed optimized markup. And this had some effect on our Google search results. I don't think that the move from a traditional CMS to the JAMStack had an effect. But with the move from a traditional CMS to the JAMStack, we were able to focus on performance and on speed, and this had some effect. This had actually a lot of effect. So especially since we had two approaches. We had those people who were caring about the content, and then we had some people who were only caring about connections between sites and not having any 404s and stuff like that. All this having the content mesh of the website finely tuned, and they were really happy to work with the JAMStack because they were able to do big changes in just one file, because they were able to hack the templates directly and stuff like that. So more beneficial than others. So yeah, that's all I can tell about that. Sam had a question back there.
Just some anecdotal evidence about this. We had this site that was completely statically published, and we noticed that compared to other projects we had, it had a way higher crawl budget from Google. Now, did it affect the rankings? I don't know. But we had a way, considered for the site, the traffic and everything, the crawl budget was a lot higher than what we had on different other sites. And we figured it's because we responded so fast that the Google bot didn't care, but just anecdotal evidence.
Very good. The one feature that I wish a headless CMS would have, a preview mode. Having a draft callable via the same API than the public result. This is something that I've seen in commercial products, but not in open source products. And I guess this is the one thing that makes headless fly and JAMStack fly. If people are able to get real-time results of what they're editing in a front-end view. Is that on the roadmap?
We've got preview in the non-headless version, and it's
cool.
We're aware of it.
Very cool.
Figured out how to fix it yet.
Anything else?
Okay,
right.
So thank you very much, Stefan.
Thank you for having me.